Okay, here's a review for your next test, chapters 8 through 11. Um, there was bonding. Remember the different types. And again, the way you're going to do this is you're going to look at their electronegativity and the difference between them. Remember, if it's 0 to 0.3, it's non-polar covalent. If it's 0.3 to 1.7, it's polar covalent. So both covalent, they're sharing electrons. But if they're not sharing them equally, that's polar covalent because they have poles. And then if there's a big difference between them, that's ionic, 1.7 or higher. And remember, ionic is between a metal and a non-metal. If you have, in this case, like two non-metals, chances are it's going to be covalent. You'll just have to figure out using the numbers. And you should have a chart. I don't know if you can see it, but it looks like this, and it has the numbers on it. Okay? So calcium and fluorine, that would be ionic because those guys have high numbers. Sulfur and selenium, if you look on here, sulfur's 2.5 and selenium's 2.4, so the difference would be 1.1, so that would be nonpolar covalent. Okay? And iron and nickel, iron is 1.8 and nickel is 1.8, so again, that doesn't form a bond. Why? Two metals, you guys. Anytime you have two metals, it's not going to form an ionic or a covalent bond. You can't look at the electronegativities. If you put two metals together, basically, it's not going to form a bond in this way. And the other thing that won't form a bond is if you put noble gases together. Okay, because noble gases don't form bonds. Okay, so if you have two metals or if you have a noble gas, no bond. Okay, the shape of the following, remember you draw them. Nitrogen would have a triple bond between them. And because it's only two, it's linear, okay? CO3, you'd have carbon with 3 oxygen around it. Remember that -2 means I get to add 2 electrons, and you'll see they belong in there. But 3, basically you're going to look for a lone pair, and if there's not a lone pair, it's trigonal planar. If there's a lone pair, it'd be trigonal pyramidal. Okay, O3, there's 3 oxygen, there's one with a double bond, one with a single bond. That's going to be bent because you have a lone pair in there, okay? If there's no lone pairs, it's linear, but if there's a lone pair, it's bent. Okay, CHBr3, you'll have carbon in the middle, and you'll have 1 hydrogen and then 3 bromine around it. So there's going to be 4 bonded to the central atom. That's tetrahedral. Okay, PClO3, again, because there's 3, you know it's either planar or pyramidal, trigonal planar, trigonal pyramidal. I'm going to look, and phosphorus has 5 valence electrons. So again, it's going to be pyramidal because it has a lone pair. So draw your Lewis structures, and if you forget, there's that video. Watch the video again on how I showed you to do it, and then look. You look at the guy in the middle and how many are bonded to it. Well, you can tell how many are bonded to it. There's 3 bonded to this one. There's going to be 2 bonded to this one because one's going to be in the middle. There's going to be 3 bonded to this one, and you got 1, 2, 3, 4 bonded to this one. So you look for bonded pairs and lone pairs, and that tells you the shape. In CO, carbon monoxide would be carbon with a triple bond oxygen. It's only 2. Whenever it's only 2, this guy, it has to be linear. There's no other option because there really is no central atom. Okay? This is me being full of hot air. Okay? You have your volume. I think this might even be one of the problems I gave you on your quizzes. But again, this is a Charles law. So you look at the formulas and just fill them in. First volume, 2.2 at 18 Celsius. Remember, you got to change that to Kelvin. The second temperature, so this one would be up here and the first one would be down here. And again, both of them change to Kelvin. Just fill in your numbers, multiply and divide, and you'll have your answers, okay? And again, you should have a gas laws cheat sheet that has all the formulas on them, okay? Make sure that printed out, and that'll help you. Okay, a sample gas has a pressure of 699 millimeters of mercury at 40. What is temperature at standard pressure? Remember, standard pressure, if you're using millimeters of mercury, would be 760. If you're using atmospheres, it would be 1. So it's whatever the standard is. And again, that's on that cheat sheet that I gave you. So the second temperature, that's what we're trying to find. Take the second pressure, which would be 760, times the first temperature, change that to Kelvin. So what would that be? 313. And then divide by the first pressure, 699. Okay, so 760 times 313 divided by 699, and there you have your answer. Okay, and again, remember, you got to change all the temperatures to Kelvin. All you have to do is add 273 to them, and then just find your formula and plug in the numbers. Okay, here's another one. We got moles of gas, we've got volume, we've got temperature. What's the pressure? So if we got moles and liters, and this is ideal gas law, remember pressure volume equals number of moles times the gas constant times temperature. That's the thing. So if I rearrange and I'm trying to find pressure, I know it's PV equals, so I'm just going to divide. So I'm going to take number of moles, 3. R, that's gas constant, 0.0821. That never changes. And my temperature is already in Kelvin, 400. And then I'm going to divide by 60. And then you get your answer. Again, this is the ideal gas law. And that R is 0.0821. It never changes. And again, that's on that gas cheat sheet that I gave you. So, okay, here's another one. Okay, this is pressure, volume, temperature. This is a combination gas law where we have all of them, where we use Boyle's, Charles, and Gay-Lussac's law. So again, you're just going to redo your formula. This was over here, and then just plug in your numbers. Your first pressure was 78. Your first volume was 21. Your second temperature was 750. Your first temperature was 900. And your second pressure was, where is that? What is the volume? 78. What am I missing? Oh, 45. Sorry, I can't read. 45. So just plug in your numbers, multiply and divide, and you'll get your answer. And again, this is just a matter of finding the right formula. Make sure that you have your gas laws cheat sheet, and that'll help you find all these. Okay. What is the volume of 34 grams of carbon monoxide at STP? Remember, all gases at STPs, their volume is 22.4 liters. It doesn't matter what gas you have. So you take your 34 grams of carbon monoxide, you'd have to change that to moles. So that's not so hard. Take 34. The 28 is carbon and oxygen. 12 and 8 and 16 is going to give me my 28. It's just what it weighs. Again, you have that app on your phone if you want to use that. So 34 times 22.4 divided by 28. So what is the volume of 34 grams at STP? 27.2. This is more than 1 mole. It should be a little bit more. Okay, this is what 1 mole is, so that makes sense. Okay, if this was less than that, then I'd go, ooh, I messed up somewhere. Okay. Okay, here's another one. We've got temperature 14, volume, temperature. Oh, so this is just a Charles volume temperature. And so we plug in the numbers. The biggest thing is make sure you change your Celsius to Kelvin. Plug in your numbers and then multiply. So the gas laws, again, there's a lot of them, I know. But you have all the formulas. You have Boyle's law, which deals with pressure and volume. You have Charles' law, which deals with temperature and volume. You have Gay-Lussac's, which is pressure and temperature. And then there's a combination where you combine those. You have your ideal gas laws, which is the pressure times volume equals moles times gas constant times temperature. You know, so there's all those laws, but again, it's just looking at the thing. And remember, oh, this is a Dalton's pressure one. You know what? I didn't show you any of these. But remember, when you're talking about pressure, it's just adding all of them together. Let me show you how to do this. I would find the pressure for each one. So container A has a volume of 1.56 under a pressure of 185.3. So I would multiply those two. Now for my volume, because I'm going to put them all in one container, I would just add all these volumes together from A, B, and C. Whatever the new container. The new container is going to have a volume of 90.95 liters. So for A, I would take my pressure one and volume one, and then I divide by 0.95, and I'd get for A. And then I do the same thing for B. I take 0.52 times 370.6, and then I divide by 0.95. And then I do the same thing, and then I just add them together. Okay, so you do A and you do B. And then for C, because this is your new container, basically what they're saying is you're taking container A and container B and putting them together. Okay, so the new volume is going to be what container C is. So you just take each individual and add them up. That's partial pressures. So if you're doing partial pressures, you basically do each individual and you just add them together. Okay. Okay, this is a phase change one. the ones we did in chapter 11, how much heat is needed to heat 25 grams of water from 25 Celsius to 110. So the first thing I'm going to have to do is I'm going to have to take my 25 grams of water and I'm going to have to get it up to 100. So 25 to 100 would be 75 degrees. So you're going to take the amount of heat is going to be mass, 25, times the change in temperature, which now I'm only going to 100 because that's where it boils. So it'd be 75, and then the specific heat of water is 4.18. Okay, so that's my first thing. And again, remember I switched these to kilojoules because I got to add them all together if I'm doing a phase change. So just move it over 3. If that confuses you, just divide by 1,000. Okay, then I got to do a phase change. Okay, my phase change is going to be my 25 divided by its mass. Water's molar mass is 18. That's 2 hydrogen, 1 oxygen. And then I multiply by its the heat of fusion. I mean the heat of vaporization, sorry, is 40.67. So I take 25 and I divide by 18, and that'll give me my moles. And then I multiply this. So I get 56.4. If you put 56.5, that'd be fine, kilojoules. Now I got one more thing to worry about because I got it up to 100. Now I got to go to 100, from 100 to 110. So again, I got to go back to here, but now I'm going to use a different specific heat. I'm not going to use water. I'm going to use steam. So again, I go 25 times 10. That's my change in temperature from 100 to 110 times 1.84. That's the specific heat, or the heat of vapor. No, what is it called? What do they call that? CP. Anyway, this is the amount of heat it takes. Okay, that's how it absorbs it. Or heat capacity. That's the word I'm looking for. Heat capacity. Okay, so here's the heat capacity for steam, and then I multiply. And again, I have to change that to kilojoules, so it'd be 0.46. Okay, and then you just add them all together. Okay, so again, when you're doing a phase change, you got to go from wherever you're at to the first phase change. And again, when you're using water, you got 0 as where it melts and 100 where it boils. Okay, so 25 times your change in temperature times the heat capacity of water, liquid water, is 4.18. Then you got your joules. Then your phase change, you take the mass times its formula mass for water is always 18, that's what it weighs, and then you multiply by the heat of vaporization. And again, these I always change to kilojoules because this one is in kilojoules. And then you got to finish it off. You still got your 25 grams of water, but now it goes from 100 to 110 times. This is the heat capacity of steam. Okay, and then you just add them together, and that's how you find your total. And I think that's it. Oh, we got one more. Oh, dry ionic bonds. Remember when you're doing ionic bonds, you'd have lithium with 1 dot, oxygen with 6 dots. Well, the first thing I would do is I would write the right formula, because lithium is +1, oxygen is -2, so it's going to be Li2O. So I know I'm going to need 2 lithium with 1 dot and 1 oxygen with 6, and then I'm just going to transfer them over. Magnesium has 2, bromine has 1. So again, if I go MgBr, put their charge as +2, -1, it's going to be MgBr2. So I'm going to have magnesium with 2, and then each one's going to transfer over. So I need 2 bromine because they have 7. So each one gets 1. And remember, when you do ionics, you have to put in the charge. So lithium gives up 1, it becomes +1. Oxygen takes in 2, it becomes -2. It's the same as their oxidation numbers on that chart that you have with all the charges. Okay, aluminum and sulfur, you'd have to do 2 aluminum and 3 sulfur. And again, write the formula first and then you'll see that. But you've got to make sure that aluminum gives up all of its electrons and sulfur takes them all in. Okay, so that's that. Your test, it'll be right after this. And again, make sure you have all your notes, make sure you have your materials ready, all the charts. You'll have a lot of charts, I know. You have your chart with shapes. You'll have your chart with electronegativities. You need to make sure you understand what the valence electrons are. So you have all that stuff. Make sure you have it with you when you're ready to go, and should be a piece of cake.